Chapter 8, which is the binomial expansion. And section 1 is Pascal's notation, factorial notation. With that said, let's begin. Okay, so the sun is like shining directly on me, so I have to close that. Okay. State every entry of the row of Pascal's triangle which begins 1, 6. The answer is 1, 6, 15, 20, 15, 6, 1. We recall Pascal's triangle, 1, the rows of Pascal's triangle, one after the other. So it goes 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. Evaluate 7 factorial divided by all of 5 factorial times 2 factorial. Dividing 7 factorial by 5 factorial means that all we have to do is 7 times 6, but then dividing that by 2 factorial means that all we have to do is 7 times 3, which is 21. So 21 is 7 factorial divided by all of 5 factorial times 2 factorial. Evaluate 10 factorial over 8 factorial. That would be 10 times 9, which is 90. So 90 is 10 factorial over 8 factorial. Find the sum of all the entries in the row of Pascal's triangle whose second entry is 9. Okay, so the row that goes 1, 2, 1 sums to 4, and the row that goes 1 through 3, 1 sums to 8. So I hope you can detect that the sum of the rows is the powers of 2. So in this case it would be 2 to the 9, which is 512. That is to say, 512 is the sum of all the entries in the row of Pascal's triangle which begins 1, 9. Simplify n add 2 all factorial over n factorial as a quadratic in n. Okay, this would be n add 2 times n add 1, which is n squared add 3n add 2. So n squared add 3n add 2 is the simplification of n add 2 all factorial over n factorial. Hello! Section 2. Binomial coefficients and n choose R. Evaluate 8, choose 3. We may use the formula, which would be 8 factorial over 5 factorial times 3 factorial, and thus we get 8 times 7 times 6 over 6, which is 8 times 7, which is 56. So 56 is 8, choose 3. And yes, I have a big one. Next, evaluate 10, choose 2. 10, choose 2. So by the same logic, this is 10 times 9 over 2, which is 45. And recall that n choose 2 is the n minus 1 triangle number. Hello. Given n choose 2 equals 45 for a positive n, find n. So we just did that, and thus n 10 is n, because 10 choose 2 is 45. It's 45. Isn't it? Yes, it is. It's 45. Okay, so we're also going to change the numbers there. Yep. Evaluate 12, choose 10. 12, choose 10. So this would be 12 factorial over 10 factorial times 2 factorial, which is 12 times 11 over 2, which is 6 times 11, which is 66. And 12, choose 2 is, of course, the 11th triangular number. Given n choose 3 equals n choose 5, find n. The answer would be 8. N is equal to 8 because 8 choose 3 is equal to 8 choose 5. All right. Section 3. Expanding a at bx all to the n for a positive integer n. Expand 1 add 2x all to the 4 completely. Okay, so the coefficients will be 1, 4, 6, 4, 1. As the first term is 1, it doesn't really matter. And then we just have to be careful about raising 2x to the relevant power. Okay, so that means it would go 1 plus 8x plus 24x squared plus 32x cubed plus 8x to the 4. So those coefficients are 1, 8, 24 32 16. So 1 add 8x, add 24x squared, add 32x. So 1 add 8x, add 24x squared, add 32x cubed, add 16x to the 4 is the full and complete expansion of 1 add 2x all to the 4. Expand 2 take x all cubed completely. Okay, so in this case it would be simpler just to square it and then multiply it by 2 minus x. So when we square it, we get x squared take 4x at 4. Hello. X squared take 4x at 4. Has to then be multiplied by negative x plus 2. So it would be, alright, that's kind of difficult to keep in my head. So the coefficients are minus 1, 6, minus 4, and eight. Minus 1, 6, minus 4, and 8. Resulting in negative x cubed 6x squared minus 4x plus 8. So negative x cubed plus 6x squared minus 4x plus 8 is the complete expansion of 2 minus x all cubed. Okay. You are completely right. Mathematics is the best. Expand 3 add x all cubed completely. We square it to get x squared add 6x add 9. Then multiply by x at 3. The coefficients will be 1, 9, 27, and 27. And thus we get x cubed add 9x squared add 27x at 27. So x cubed at 9x squared at 27x at 27 is the complete expansion of 3 at x all cubed. Expand 1 minus 2x all to the 5 up to and including the x squared term. Now we must use the binomial expansion. Alright, so the first term is simply 1. For raising a binomial to the power of 5, that row will start 1, 5, 10 with the coefficients. And then we know that the first term, i.e. the a term being 1, means it's irrelevant. And we also know that it will have the alternating plus or minus pattern. So it will go 1 minus 10x plus 40x squared. So 1 minus 10x plus 40x squared. So 1 minus 10x plus 40x squared and so on is the binomial expansion of 1 minus 2x all to the 5 up to and including the x squared term. Find the sum of all the coefficients in the full expansion of 1 add 3x all to the 4. Alright, so on Pascal's triangle we use the row that goes 1, 4, 6, 4, 1. And then we know that the coefficients from the 3x term will be 1, 3, 9, 27, 81. And then we just need to find the products. That is 1 times 1 plus 3 times 4 plus 9 times 6 plus 27 times 4 plus 81 times 1, which is 1 plus 12 plus 54 plus 108 plus 81 is 256. So 256 should be the sum of all the coefficients of the full expansion of 1 add 3x all to the 4. Okay, next section is finding a specified term in an expansion. Find the coefficient. Is it malfunctioning? No, it seems to be fine. So find the coefficient of x cubed in the expansion of 1 add 2x all to the 6. So that term, we can ignore the fact that a is equal to 1, so it would be 2x all cubed, multiplied by what though? (20). And thus the answer would be 160. So 160 should be the coefficient of the x cubed term in the full expansion of 1 add 2x all to the 6. Find the coefficient of x squared in the full expansion of 3 take x all to the 5. Okay. So that row in Pascal's triangle that we're trying to draw from is 1, 5, 10, 10, 5, 1. And for x squared we are interested in 10. And then it will be positive. And then we also have to cube 3, and thus it will be 270. So 270 will be the coefficient of x squared in the full expansion of 3 minus x all to the 5. Find the term in x to the 4 in the full expansion of 2 add x all to the 7. Okay, so we have to cube 2 and then also multiply that by 7 choose 3, right? That's right, isn't it? So 35 times 2, which is 70. So 70 is the x to the 4 term in 2 add x all to the 7. No, 70x to the 4 is the x to the 4 term in 2 add x all to the 7. Hello! Find the coefficient of x to the 5 in the full expansion of 1 take x all to the 10. Okay, so it will be negative, and it will be 10 choose 5. And 10 choose 5 is what? Ten times 8 times 7 times 6 all over 120. Okay, so you can cross off 10 and 6, so 9 times 8 times 7. And then you can turn that into a 3, so 3 times 8 times 7. And then 24 times 7 is 168, and 168 is the coefficient of x to the 5 in 1 take x all to the 10. Negative 168. In the expansion of 1 add kx all to the 5, the coefficient of x squared is 90. Find the positive value of k. Okay, so the row that we need is 1, 5, 10, 10, 5, 1, and then we'll use 10, and therefore k is 3. So the positive value of k is 3 in the expansion of 1 add kx all to the 5, where we're looking at the coefficient of x squared. Hello. Okay. The last section is using binomial expansions for estimation. Okay, let's do it. Using the first 3 terms of 1 plus x all to the 8 and letting x equal 0.01, give an estimate for 1.01 to the power of 8. Okay, so the 1 contributes nothing, and then we just need the first 3 coefficients in that row of Pascal's triangle that begins with 1, 8. So the next number after that is the 7th triangular number, which is 28. So it should actually be 1.010. It should be 1.0856. 1.0856. Okay, and now using terms up to x squared in the binomial expansion of 1 take 2x all to the 5, where x is equal to 0.01, estimate 0.98 to the power of 5. Okay, so one, 5, 10, 10, 5, 1 is what we need. And we need to subtract away 5 lots of 0.01 times 2. Come on. 1, 5, 10, 10, 5, 1. So 1 take 10x plus 40x squared. 1 take 10x plus 40x squared. Alright, so take away 10 lots of 0.001. Okay, so that'd be 0.90. Okay, and then add 40 of it when you square it. Alright, so fine. So that would be 0.9040. Using the first 3 terms of 1 add x all to the 10 with x equaling 0.0. I can't remember. Using the first 3 terms in the binomial expansion of 1 add x all to the 10 with x equaling 0.002, estimate 1.002 all to the 10. Alright, so the first 3 terms are 1 plus 10x plus 45x squared. And so it should be 1.020090. Hello. Using the terms up to x squared in the expansion of 2 at x all to the 4 with x equaling 0.01, estimate 2.01 to the power of 4. Okay, so 2 at x all to the 4. The first term is 16. The second term is 32x. And the third term is 24x squared. 16 and 32x. Alright, beg your pardon, I just heard a number, so let me just do that one more time. So I'm expanding 2 at x all to the 4. So the first term is 16, the second term is 32x, and the third term is 24x squared. 16 and 32x at 24x squared. Okay, so that would be 16.24, 16 point 16.3224. Okay, and last. Hello. Using the terms up to x squared in the binomial expansion of 1 take x all to the 7 and taking x to be 0.01, find an estimate to 0.99 to the 7. Okay, so the first term will be 1. The second term will be negative 7x. And the third term will be (21x squared). Okay, and so that will be 0.93 0.9321. Okay, so that completes that, and now these have to be checked. Now, I'm not expecting stellar results from this because these were genuinely difficult to keep track of, but we do it again. That's fine, that's fine, that's fine. Yep. Okay, just one term wrong there. That's okay. Okay, that expansion is not right. That's not right either. Okay, and now these ones are really tough for me. Okay, so yes, like I say, really difficult. 20 out of 25. But still a pass. We do it on another date. And now, chapter 9. Which is trigonometric ratios. And section 1 is the cosine rule. Right, let's get ready. Okay. Right, let's do it. Put that there. Put that there. And let's do it. Okay, so we need to be careful with this. In a triangle, two sides of length 5 and 8 enclose an angle of 60 degrees. Find the length of the third side. So we use states a squared equals b squared plus c squared minus 2bc cosine of squared. Take 2 times 5 times 8 times the cosine of 60. Okay, so that means 25 at 6 plus the third side is 7. So the third side is 7 in the triangle with two sides of length 8 and 5 enclosing an angle of size 60 degrees.